Hello everyone and welcome back to hopefully the last, and only two questions left. So yes, the last session of simulation. Let's come to the questions that are left, and now we are going to do that question where actually simulation is applied and a lot of things are studied. It's a very typical question. It's a very good question. And these are the kind of experiments where simulation is actually used. So let's come back to the question that I want to do. And that question is question number 6. What does question number 6 say? After observing heavy congestion of customers over a period of time in a petrol station, Mr. Petro, very convenient, Mr. Petro has decided to set up a petrol pump facility on his own in a nearby site. So Mr. Petro, probably a businessman or somebody who's been observing that petrol pumps are very busy in this area. So he decided that I will start a petrol pump of my own. He has compiled statistics relating to the potential customer arrival pattern and service pattern as given below. So he has studied two things: customer arrival pattern and customer service pattern. He has studied that, and he has also decided to evaluate the operations by simulation technique. So he studied two things: arrival and service. So number one, arrival and probability. Now they've written something like arrival, and below that they have written inter-arrival time. What does that mean? I will tell you. And probability is given. Service time in minutes and probability is given to you. So service is written as a time, but arrival is not written as a time. Arrival is written as an inter-arrival time. I don't know what that means for now. I will tell you once we begin the question. Number one, assume the clock starts at 8 hours, which means at 8 o'clock you start service. Number two, only one pump is set up. Okay, only one pump is set up. Number three, the following random numbers are to be used to depict the customer arrival pattern. So for arrival, those are the random numbers that I have to use. And the following 12 random numbers are to be used to depict customer service pattern. So the first 12 are for arrival, the second 12 are for service. You are required to find out probability of pump idle, average time spent by a customer waiting in queue. Oh, this sounds familiar. This is queuing theory, no? But here they don't want you to do it using queuing theory. Here they want you to do using simulation. So this is like a scheduling technique or like a queuing theory where a queue is being formed. So it's a petrol pump where people come to get service, but there is a queue. The only difference is they haven't given you the average number of people that come to the pump, average number of people that can be served in an hour. All that is not given to you. This question is given as a probability based question, and that is why we are asked to do this in simulation and not in queuing theory. Let's get the question in. What is it exactly trying to say? Number one, Mr. Petro realized that there is very few petrol pumps in this area, and I want to start a petrol pump. But before he starts a petrol pump, he wants to analyze two things about a petrol pump: probability of a pump being idle and average time spent by a customer waiting in queue. Okay. How does he want to do this? Well, he wants to do this using simulation technique. And what has he given you? He has given you two things, or rather he went to a petrol pump and studied two things about that petrol pump. Number one is arrival time and the probability, and service time and the probability. So what I can do for you is, to begin with, which I told you remains standard in every question. Number one, I will take the arrival, I will take the probability of arrival. I will take the service and probability of service, create a cumulative probability and create a range out of it. Use the random numbers to predict the arrival of the 12 customers and predict the service of the 12 customers. Fantastic. Let's begin. So, to begin with, obviously the question, and like I said, this is too many tables. So, like in every question, let me get the table ready. So, we have arrival, the inter-arrival time and its probability, service time and its probability. So, we start with arrival, 2, 4, 6, 8, 10. Probability of that arrival, 0.22, 0.30, 0.24, 0.14, 0.10. Cumulative probability, 0.22, 0.52, 0.76, 0.901. Range for arrival. This is basically 22. So it's 0 to 21, 22 to 51, 52 to 75, 76 to 89 and 90 to 99. The same for service. 4, 6, 8, 10. Probability of that service, 0.28, 0.40, 0.22, 0.10. Cumulative probability, 0.28, 0.68, 0.90, 1. Range 0 to 27, 28 to 67, then you have 68 to 89, and then lastly 90 to 99. Done? So with the arrival and the probability, I created a range for arrival. With the service and the probability, I created a range for service. Next is here. Number 1, customer number. Well, customer number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is going to be a random number for arrival. Then there will be an arrival time, which is basically the inter-arrival time. Then there will be a random number for service. And then there will be a service time. This is the basic that I can predict. Then what you want, I will give you later. Let me finish off the prediction. I need the random numbers. Fine. Let's bring out the random numbers. So random number here will be, yes. Random number for arrival is 78, 26, 94, 78, 26, 94, 8, 46, 63, 8, 46, 63, 18, 35, 59, 18, 35, 59, and lastly 12, 97, 82, 12, 97, 82. Let's start that with service. So service random numbers are 44, 21, 73, 44, 21, 73, 96, 63, 35, 96, 63, 35, 57, 31, 84, 57, 31, 84, 24, 5, 37, 24, 5, 37. So I have customer number 1 to 12, 12 customers. For these 12 customers, I'm going to predict an arrival and I'm going to predict a service. How am I going to do that? I have that right here. So number one, I'm going to get rid of the PDF. And number two, because it's on the same table, it's on the same page, but it will not fit. I will have to unzoom a little. Does this fit now? Yes, very much. Perfect. Let's start. 78 falls here. Inter-arrival time is 8 minutes. 26 is here, 4 minutes. 94 is here, 10 minutes. 8 is here, 2 minutes. 46 is here, 4 minutes. 63 is here, 6 minutes. 18 is here, 2 minutes. 35 is here, 4 minutes. 59 is here, 6 minutes. 12 is here, 2 minutes. 97 is here, 10 minutes. 82 is here, 8 minutes. The same for service. 44 is here, 6 minutes. 21 is here, 4 minutes. 73 is here, 8 minutes. 96 is here, 10 minutes. 63 is here, 6 minutes. 35 is here, 6 minutes. 57 is here, 6 minutes. 31 is here, 6 minutes. Then you have 84 is here, 8 minutes. 24 is here, 4 minutes. 5 is here, 4 minutes. And 37 is here, 6 minutes. Done? After having done this, I have the arrival and I have the service. What do you want me to do? So, like for example, customer number 1 arrives at 8 and gets 6 minutes of service. Customer number 2 arrives at 4 and gets 4 minutes of service. What? Customer number 2 arrives at 4. This is something odd. Fine. Let's see what they are asking of you. After observing heavy congestion at, okay, sorry, let's skip all of that. Come below the table because that is where they are asking you whatever they are asking you. Assume that the clock starts at 8 hours. Okay. Only one pump is set up, which means only one server is there to provide service. The following random numbers. You are required to find out the probability of the pump being idle and the average time a customer has to wait in queue. Oh, so I have to play this out. Okay, then I kind of understand what is it that you are looking for. The clock starts at 8. Well, clocks never start or stop. Your petrol pump starts at 8 is what that means. And you know what this inter-arrival time means? Arrival, correct. But when I say that the petrol pump starts at 8 and the arrival of the first customer is 8 minutes, why they had written it as an inter-arrival time is because what it means is the time between two arrivals is 8. The time between two arrivals is 4. The time between two arrivals is 10. Or in other words, your workshop starts at 8. The first customer arrives 8 minutes after that. So the first customer arrives at 8 hours and 8 minutes. The next customer arrives after 4 minutes that the first customer had arrived. 8 plus 4 is 12. So the next customer arrives at 8 hours and 12 minutes. Inter-arrival time. Inter meaning between. So the inter-arrival time is 4 minutes. 8, 8 and 8, 12. What do you want me to find? The probability that a pump is idle, meaning that nobody is getting service at the pump, and the average time that a customer has to be idle. The customer is waiting in line. Okay, so to calculate that, you know what I need to do? This is what I need to do. Petrol pump starts at 8. 8 the first customer comes, takes service for 6 minutes. 8 plus 6 is going to be 8 9, 8 10, 11, 12, 13 and 14. The first customer finishes at 8:14. But the next customer has been here since 8:12. Oh, so that customer had to wait for 2 minutes. So can I say I need to draw a table where I need to write customer number, I need to write the inter-arrival time and find out when do all the customers arrive. Then I need to write down the service time for that customer, and then starts an in and an out. Customer walks in at 8:08, walks out at 8:08 plus 6, which is 8:14. After that, two things might happen. If there was nobody at the pump, then the pump was idle. If a customer had to come and wait for somebody else's service to be done, then there was a customer waiting. So what are the kind of columns that I need? Number one, I need a customer number. I need a arrival time or an inter-arrival time, which will give me the actual arrival time. I will need a service time, which will give me an service in, service out, which will give me a customer idle, and which will give me a petrol pump idle and a customer waiting. So I'm basically looking for a total of 8 columns. Okay, I'm going to draw a table with 8 columns. So while I do that, let me pause it to not waste time. So here I have my table ready. Column number 1 is going to be customer number. Customer number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is number 1. The next is inter-arrival time. That I will have to copy from behind. So let me do that quickly. Now this inter-arrival time will give me the actual time or the actual arrival time or the arrival time. Clock starts at 8 a.m. If they would have said 9, then I would have considered 9. Here they are saying 8, so 8 a.m. Which means first customer comes 8 minutes after that. Which means first customer comes at 8:08. The next comes 4 minutes after that. So 8:08 plus 4 is going to be 8:12. Plus 10 is going to be 8:22. Plus 2 is going to be 8:24. Plus 4 is going to be 8:28. Plus 6 is going to be 34 if I am correct. 24 plus another 28 plus another 6 is 34. So 8:34, 8:36, 8:40, 8:46, 8:48, 8:58, and 58 plus 8 will be 66. But don't make that mistake. It's not 8:66. There is no clock. After 60, it adds 1 to the next. So it is 9:06. This is how customers arrive, or this is the customer arrival pattern. Next is going to be the service time. which I will copy from the prediction that we made. So let me do that quickly. Done. So I have inter-arrival time. From that I found the arrival time. I have service time. Now what will happen? The customer will come at 8:08, start taking service, will take 6 minutes of service and walk out. So there will be a service start and a service end. So let me make that change here. Service in out, or you can write service start and service end. Perfect. Let's begin then, and this is the main part. You need to pay attention. 8:08. Customer came, arrived at 8:08. So can the service start at 8:08? Yes. Petrol pump has been open since 8 o'clock. You came at 8:08. There is nobody else. You are the first one. So can service start at 8:08? Definitely yes. The service starts at 8:08 and the person takes 6 minutes of service. 8:08 plus another 6 is going to be 8:14 and service ends at 8:14. Now whenever this happens, two things that will arise, or two situations that will arise. Either there is somebody already in queue, so the customer has to wait, or there is nobody for service, so the petrol pump is idle. Either of the two. So these are the two columns. The first one is going to be customer waiting, and the second has to be pump idle. So I just want to get an idea, because if too many customers are waiting or customer has to wait for too long, I will put one more pump. If the pump is idle for a really long time, I will make measures and tell the guy that, listen, the pump is idle for too long, I can't pay you for that much. Whatever it is, that declaration comes later. When the first iteration happened, which is customer came at 8:08, service took 6 minutes, 8:08 start, 8:14 end. What happened? Was the customer waiting or the pump idle? Well, the customer was not waiting. The customer came and started service. The pump opened at 8 o'clock, but this guy came at 8:08, or service started at 8:08. Then can I say the pump was idle for 8 minutes? There was no customer waiting. Let's move to the next one. The next customer is here at 8:12. Can the service start at 8:12? No. Why? Because at 8:12 the pump is not free. The first customer is still getting service. Then can I say the second customer will come at 8:12, but service will only start at 8:14 after the first customer has done getting service. Then can I say that this customer came at 8:12, service started at 8:14, this customer was waiting for 2 minutes. The pump is not idle, because after giving this person service, the pump will immediately start giving the next customer service. Service starts at 8:14, takes 4 minutes and ends at 8:18. At 8:18, service is done? Yes. The next customer comes at 8:22. Can service start at 8:22? Yes. Because the previous person's service has already finished at 8:18. So at 8:22, service can directly start. Did the customer have to wait? No. The pump was idle from 8:18 to 8:22, which is basically 4 minutes. No customer had to wait. Service starts at 8:22, takes 8 minutes and ends at 8:30. The next customer is here at 8:24. Can he take service at 8:24? No. Service can only begin at 8:30 after the previous customer is done. Then can I say this customer had to wait for 6 minutes? Service starts at 8:30, takes 10 minutes and ends at 8:40. The next customer is here at 8:28. Can service start at 8:28? No. The pump is not free. It will finish service at 8:40. So you can start at 8:40. If the customer arrived at 8:28 and service starts at 8:40, then can I say there is a 12-minute waiting? Yes. So the customer had to wait for 12 minutes. 8:40, 6 minutes for service, out at 8:46. Is the next customer available at 8:46? Yes. The next customer has been waiting since 8:34. But at 8:34, he or she couldn't take service because the pump was still working on the previous customer. So service can only begin at 8:46. If service begins at 8:46, then the customer who came in at 8:34 had to wait till 8:46. From 8:46 to 8:34, there has been a 12-minute customer waiting. 34, 44 and then another 2. There is no pump, idle. Service starts at 8:46, takes 6 minutes. It is going to end at 8:52. The next customer is here since 8:36. So can service start at 8:36? No, service will start at 8:52 after the previous customer is done. Which means that this customer has been waiting since 8:36 up to 8:52, 46, 56. 56 I am overshooting. So 52 minus 36 is going to be 16 minutes. Once again, 52 minus 36 is 16 minutes. So this customer was waiting for 16 minutes. 6 minutes of service gets done at 8:58. Is the next customer available at 8:58? The next customer has been here since 8:40. So service will only start at 8:58, which means this customer was waiting for 18 minutes. Service starts at 8:58 and takes 6 minutes. 58 plus 6 is going to be 64. Well, I can't write 64. 60 minutes will make it 9 o'clock and then another 4. So it is going to be 9 and 4 minutes. Is the next customer available at 9:04? Yes. The next customer has been here since 9:40, 8:46. Service will start at 9:04, which means this customer had to wait for 8:46 to 9 o'clock is going to be how much? Is going to be 14 minutes. And then another 4 minutes is going to be 18 minutes. 18 minutes of waiting, 8 minutes of service. 8 plus 4 is 12. So will be done at 9:12. Is the next customer available at 9:12? Yes. The next customer is been available since 8:48. Then take the customer in for service at 8:12. At 8:12, if the customer has gone in for service, there has been waiting of 12 minutes here. and 48 to 60 is 12 minutes here. 12 plus 12 is 24 minutes. Was waiting for 24 minutes. 8:12 service started, took 4 minutes. Sorry, 9:12 service started, took 4 minutes. 9:12 plus 4 is 9:16. 9:16, the next customer will start getting service, which means the customer was waiting for 2 and another 16, which is a total of 18 minutes. 9:16 service starts, takes 4 minutes and ends at 9:20. 9:20 is the next customer available? Yes. The next customer is here since 9:06, which means he or she had to wait for 14 minutes. 9:20 plus 6 minutes of service is 9:26. And that is how this question is done. It's a very interesting question and it's asked in different ways. Like I told you, your initial institute material used to be very beautiful. It had a lot of different types of questions. So in this, remember the queuing theory, Wanda's car wash question? In that, remember it was a fixed service time. So in this, no, they sometimes give you a question where they say doctors are coming to a patient, service is random, but arrival is fixed. Customers arrive starting at 8 o'clock every 20 minutes. So this is not probabilistic. So first customer at 8, next at 8:20, next at 8:40, 8:60, which is basically 9 o'clock, 9:20, 9:40, 9:60, which is 10 o'clock, 10:20, 10:40, 10:60, which is 11 o'clock, 11:20, 11:40, 11:60, which is basically 12 o'clock. And then you do the service. Here the only difference is arrival is also random, service is also random. Let's go back and find out what is it that they wanted me to find. What they want me to find is probability that the pump is idle, average time spent by a customer in queue. Okay. Probability or the chance that the pump is idle and average time spent by a customer waiting in queue. Let's start one at a time. Average time for waiting. This is the times for waiting. Let's take a total. So this is going to be 2 plus 6 plus 12 plus 12 plus 16 plus 18 plus 18, 2 plus 6 plus 12 plus 12 plus 16 plus 18 plus 18 plus 24 plus 18 plus 14 is a total of 140 minutes. So the total waiting is 140 minutes. But this total waiting is being shared by 12 customers. So average waiting time of customer is 140 divided by 12, which is 140 divided by 12 is 11.6666, 11.67 minutes. And you are asking me the probability that the pump is idle. How do you find probability? Well, probability is the total against for how long is what you want happening. Well, I want the pump to be idle. Okay, for how long is that happening? That is happening for 8 plus 4, 12 minutes. And what is the total time? Well, the total time is the pump started at 8 o'clock and last service ended at 9:26. So from 8 o'clock to 9:26 is 60 minutes plus another 26 minutes, which is a total of 86 minutes. In these total 86 minutes, the pump has been idle for 12 minutes. So probability of pump idle is idle time upon total time. So the idle time is 12 minutes and the total time that the pump was running is 86 minutes, which is 12 by 86. 0.1395, or can I say approximately 0.14, or can I say 14%? There is a 14% chance that the pump has been idle. Is that all that they are asking? I guess so. Let's find out, or let's look at their solution. Okay, so what they have done is they have done everything in one. I have done a separate table for random number and inter-arrival time, random number and service time. They have done everything in one. I would do this because I get more space for every column. This makes every column very, very, very small. Anyway, final answer remains the same, which is 0.1395, which is approximately 14% of probability, or 14% of the chance that the pump is idle, and 11.67 minutes that the pump is that a customer has to wait. And yeah, this is just basic calculation that they've written down. That's it then. Our answers match. This is my table solution, which looks far more sorted as compared to theirs. So I would prefer that you follow this. I'm keeping it on the screen for some time, so that if you want, you can take a screenshot and copy it later. But yeah, very beautiful question. Unfortunately, they don't ask any of these, but since it's a part of the syllabus, we have to do it. Let's continue to the next question. Let's come to the last question in simulation. And my problem with that question is, I think the solution is wrong. And there is no way in which you can correct the solution unless you change the question, is my point of view. I will solve the question for you and then we will go ahead. And the question is a little heavy. Heavy because there are too many things happening together. So you have to pay attention to a lot of things simultaneously. Let's go to the question. The question is question number 5. What does it say? A bookstore wishes to carry Ramayana in stock. If you want, you can exclude the Ramayana and say a book in stock. So a bookstore wishes to carry a particular book in stock. Demand is probabilistic and replenishment of stock takes 2 days. Demand is probabilistic and replenishment of stock takes 2 days. What does that mean? Replenishment, which means replenishing the stock, which means restocking, which means getting more items in stock, takes 2 days. What does that mean? They've given an example. That is, if an order is placed on March 1, okay, so if I place an order on March 1, it will be delivered at the end of the day on March 3rd. This for me is very important, and because of this is why all the problems start, or all my problems start. The probabilities of the demand are given below. So demand 0, 1, 2, 3, 4, probabilities are given to you. Each time an order is placed, the store incurs an ordering cost of ₹10 per order. This is like the economic lot sizes and batch sizes. Every time you order, there is an ordering cost of 10 rupees. The store also incurs a carrying cost of 50 paise per book per day. So there is a 50 paise carrying cost. So every time you carry a book for 1 day, it is going to cost you 50 paise. The inventory carrying cost is calculated on the basis of the stock at the end of the day. Okay, so whatever inventory will be calculated as the stock at the end of the day. So I'm going to repeat this so that this registers better. What is given to you for now is main data. There are three things. The first one is that if I order a book on the 1st of March, okay, so 1st of March I order a book, it will be delivered at the end of the 3rd of March. So this is what I understand from the question. End of the day. What do you mean by end of the day? Well, obviously when the day is coming to an end. Or in other words, can I say when the store is closing down is also end of the day in any other words? Or can I say, which means I cannot use that stock on the 3rd of March. When can I use it? On the 4th of March is my understanding of it. I'll repeat. You place an order on the 1st of March and it will be received on the 3rd of March. When on the 3rd of March? At the end of the day on the 3rd of March. Which means that I cannot use it on the 3rd of March. It will go into stock on the 3rd of March night end, but it can be used only the next day morning is again my understanding of it because you said end of the day. Other things given to you is every time you order, it costs you 10 rupees to order. And if you're carrying a book or carrying inventory, it costs you rupees 50 paise per book per day. Okay. What other information is given to you? The manager of the bookstore wishes to compare two options for inventory decision. Okay. So the manager has two choices to maintain inventory. And what are the two choices? Choice number 1 or option number 1. Order 5 books when the inventory at the beginning of the day plus order outstanding is less than 8 books. Let me repeat this for you. You will open the store. You will open the store and you will check for two things. Number 1. How many books are there in my stock? And number 2, is there any outstanding order? What will I check? How many books currently in stock? And is there an order placed which I am yet to receive? I will add the two. If the total is less than 8, I will pick up the phone and order for 5 books. I'll repeat this. Order 5 books when the inventory at the beginning of the day plus order outstanding is less than 8 books. So what will you do? One last time. The moment you open the store, you are going to check for two things. What is my order outstanding? And number 2, what is my current stock? I will add the two. If it is less than 8, I will pick up the phone and place an order of 5 books. What is the second option? Order 8 books when the inventory at the beginning of the day plus order outstanding is less than 8. So same condition. You wake up, go open the store, check for two things. How many books in stock and is there an order pending? If there is, the total is less than 8, then order 8 books. Currently, beginning first day, the store has a stock of 8 books. So today morning when I opened the store, I see an opening inventory or an opening stock of 8 books plus 6 books ordered 2 days ago. Now this is my other problem. Well, I'll tell you when I read it. 6 books ordered 2 days ago. Correct. So if let's say today is 6 books ordered 2 days ago. Am I right? So if this is where I am, this is, let's say, the 5th today. So 2 days ago, 4th, 3rd, this is where I have ordered the books. Did you just tell me some time ago that if I order on the 1st, on the 3rd it will be delivered? So if I've ordered the books 2 days ago, technically today they should be delivered. But they are changing that only for the beginning maybe. 6 books ordered 2 days ago are expected to arrive the next day. So I have ordered 6 books 2 days ago and they are expected to arrive on the next day, not on the 5th day. Is that right? Let's begin. For one last time, I will recap and I will tell you what is happening. A bookstore manager wants to decide on his ordering technique. How many books to be ordered at what point in time? For which the data given to us is data number 1. If I order any books today, it will take 3 days and it will be available at the end of the 3rd day. And my understanding is if they are available at the end of the 3rd day, I cannot use it on the 3rd day. I will use it on the 4th day morning. So they will be available to me 4th day morning. Ordering cost is 10 rupees per order. Inventory carrying cost per book per day is 50 paise. The policy that I am using is my opening inventory plus order outstanding. If this total is less than 8, I either order 5 books and second option is I order 8 books. I'm going to check the cost of both the ordering techniques. Whichever is cheaper is a good idea. Now there is one thing in this question which I'm not going to do because I don't want to emphasize on that. I want to emphasize on the latter part of the question, and that is the simulation bit of it. We've done 8 questions where the first part remains the same. Probability is cumulated is ranged. Then you pick up the random numbers, see what range they fall in and predict the demand. That part I am not going to do. I'm directly going to pick up the predicted demand. So let's come back to the question and I'll tell you what part I am assuming. So these are the random numbers. Okay, solution. Demand, probability of demand, cumulate and range. I'm not doing this. After that, they have predicted with the help of the random numbers the demand. This also I'm not doing. I'm directly copying the demand because it's too much of a time waste to do something that simple, and this is the expected demand. So let me do one thing. Let me get a table ready with the demand that I am expecting. I have my table ready. Let's begin the question one at a time. So day and demand, and like I told you, I didn't do this. I've directly copied their demand because I didn't want to waste time in something this easy. I'm interested in the other part. So what will happen? Every day you wake up, you go to the store, you check 2 things. How many books are in stock? Or in other words, your opening inventory. Let's do that first. Let's write down opening inventory. You told me that currently there are 8 books in stock. Correct? So whenever I go to the store, I wake up, I go to the store, I open the store, I check what my opening stock is and whether there is an outstanding order. Well, there is. They told you some time ago. 6 units have been ordered which are expected to come tomorrow. 6 units were ordered 2 days ago, but they are expected to come tomorrow or be received tomorrow. Check that once again. Right here. Currently at the beginning of the first day, the store has a stock of 8 books and 6 books ordered 2 days ago are expected to arrive the next day. So 6 books are coming and they are expected to arrive the next day. Okay. I will add the two. What will I add? My opening stock of 8 and 6 books outstanding. 6 plus 8 is 8, 9, 10, 11, 12, 13, 14. 14 in total. Is this less than 8? No. Then can I say I do not need to order any books? I didn't order it now. I might have to order sometime later. So let me make another column, and that column is order placed. No order placed. Why no order placed? Well, for a simple reason that I have placed an order and there are 6 books coming plus these 8 books in stock. Make it a total of 14 books, and if they are greater than 8, I don't order. I only order when they are less than 8, not less than 8. So I am not going to order. No order placed. I'm going to repeat this. Demand I have directly carried from them. I didn't do the demand bit of the simulation. I want you to do it. We've been doing it for like 8 questions now. This is not going to be difficult. There is an opening stock of 8 books, which they only told you, and they said that there is an order of 6 books which has been placed 2 days ago and is expected to arrive tomorrow. So 8 books in stock plus 6 books order outstanding is total of 14 books. Is it less than 8? No, it is greater than 8. Then I don't need to order, and that is why I said that I am not placing an order. Done. You woke up, you came to the store, 8 books in stock, 6 books coming, 14 books in total, not less than 8. I am not going to order. Let's move on with the rest of the day. If I have 8 books in stock and 3 is the demand for that day, out of the 8, I will sell 3 books. How many pending? Out of 8, when I sell 3 books, 5 books pending. So I make my next column, and that is stock at day end. By the end of the day, I will have sold 3 books out of those 8 books, and when I sell 3 books out of those 8 books, I will have a stock of 5 at the end of the day. Days ending. What happens at the end of the day? I receive orders that are pending. So let me make another column and say order received. Well, there is no order received today. There is not going to be an order received today. 6 books have been ordered 2 days ago that are expected to come the next day. Not today. They are going to come tomorrow. Okay. So let me repeat this for you. You woke up in the morning, you went to the store, you saw that 8 books are there in stock and 6 books are coming. 8 plus 6 is 14 books in total. This total is greater than 8. If it was less than 8, I would place an order. But because it's greater than 8, I don't place an order. I move on with my day. Out of the 8 books, I sell 3 books. At the end of the day, a stock of 5 books remaining. Is there any order that has come in today? No, there is no order that is coming in today. Okay, so if there is no order that is coming in today, what is my closing stock? Well, my closing stock is 5 books. Done? This you have to do every day. You wake up the next day, your closing stock for yesterday becomes the opening stock for today. You open the store and you realize there are 5 books in stock and 6 books that are going to come today is a total of 11 books. Will I place an order? No. I would place an order if the opening stock plus the outstanding order is less than 8. This is 11, not less than 8. Then I will not place an order. From the 5 books that you have, you will sell 2. You will be left with 3. Day has come to an end. You received your order of 6 books. When I am closing the inventory or I am checking my closing stock, from today, the 5 books in the morning, I have 3 books left and now 6 books have been received. So the total in my closing stock is 9 books. The closing stock for yesterday becomes the opening stock for the next day. I wake up, I go to the store and I see that 9 books are there in stock. Is there any order coming? No. There was an order that was coming, that came yesterday. There is no more order coming. So order outstanding is 0. 9 plus 0 is 9. Is it less than 8? No, it's greater than 8. Then do I need to order? No. Let me repeat this. You wake up in the morning, you go to the store. Yesterday's closing stock becomes today's opening stock. Yesterday I closed with 9 books. So today I open with those 9 books. 9 plus order outstanding. Is there an order outstanding? No. There is no order outstanding. If there is no order outstanding, then 9 plus 0 is 9. This total is less than 8? No, it's greater than 8. Then I don't need to place an order. No order placed. I move on with my day. Out of the 9 books, 3 are sold. Then at the end of the day, 6 books are left. Is that right? Am I going to receive any order today? No. Then what is my closing stock? My closing stock is 6 books. The closing stock for yesterday will become the opening stock for today. I open the store. I check my opening stock and I see that 6 books are in stock. Is there an order outstanding? No. There is no order placed in the past which is anticipated to be received in the future. So there is no order that is outstanding. So 0 outstanding plus my opening of 6. 0 plus 6 is 6, which is less than 8. And because this is less than 8, I will go ahead and place an order of 5 books. Because that is what I decided. Plan A. What was plan A? Plan A was that if your opening inventory plus the order outstanding is less than 8 books, then place an order of 5 books. This order of 5 books that I have placed will be received on, so suppose this is the 1st of March, which is when I place the order. This order will be received on the 3rd of March. So 1st, 2nd, 3rd. Which means this order will be received on the 6th day. So can I go ahead and say this order that you place today will be received on the 6th. Fantastic. Let me repeat this. You wake up, you open the store, you realize there are 6 books in stock. There is no order outstanding. 6 plus 0 is 6. It is less than 8 and hence I place an order of 5 books. If I place an order of 5 books today, I am going to receive these 5 books after 2 days or at the end of the 3rd day. I move on with my day. I have placed an order of 5, 6 books in stock, 3 is the demand. So I sell 3, I am left with 3 at the end of the day. Am I anticipating a receival of an order? Not today. Then can I say my closing stock is going to be of 3 books? The closing for yesterday becomes the opening for today. I open with 3 books. Again the same. How many books do you have in stock? 3. Is there an order outstanding? Yes. There is a 5 book order outstanding which is going to come in tomorrow. 3 plus 5 is 8. Is it less than 8? No, it is exactly 8. I place an order only if that total is less than 8. Since the total is 8 and not less than 8, I don't place an order. If I don't place an order here, I don't expect anything from the 3rd day. Let's move on. You have 3 books in the opening stock. 3 is the demand. Can I say by the end of the day, there will be 0 books left? Are you expecting any order today? No, because 3 days ago, there was no order placed. Hence, I am not expecting to receive any order. My closing stock is of 0 books. And this is from where my confusion or my problem with the question begins. Closing stock for yesterday becomes opening stock for today. How many books do I have in stock? 0. Is there an order outstanding? Yes. There is a 5 book order outstanding which I am expecting to receive today. 5 plus 0 is 5. Is it less than 8? Yes. Then I will place an order for 5 books which will be received at the end of the 3rd day. Now my question to you is, this receival of 5 books that I had placed 3 days ago is going to come to me at the end of the day, like they said. So if this is coming at the end of the day, can I use it during the day? No, it's not come only. How will I use it? Then can I say this demand of 3 books will go unsatisfied because I don't have a book with me? So technically, according to me, this should not be included, but your institute material has included this. Another problem is, if you don't include this, you don't know how to proceed with the question. Should I say that this demand of 3 is unsatisfied? I don't know. There's nothing mentioned of that sort there. And that is why even I am going to continue with the question as and how it is. And this is what they have done. What they have done is, they have said, this 5 book that I am going to receive, Give them the 3 books out of the 5 books. And that alters a lot of things. For me, it creates a lot of problems. And the problem is, I agree that I will give them 3 books out of this. So when I close at the end of the day, I have 2 books. Now people make a mistake of saying 2 books plus the 5 order that I am going to receive. No. You are assuming that you've already received this during the day, from which you have sold 3 books. And that is why the closing stock is only 2 books, not 2 plus 5, which is 7 books. This is my problem with the question. Apart from that, there is no other issue. So let me repeat what my problem is. I open the store with 0 books or a 0 opening stock. There is an order of 5 books that is outstanding, which is going to come today. 0 plus 5 is 5, which is less than 8, which means I will pick up the phone and place an order of 5 books. This order of 5 books will come at the end of the 3rd day. Fine, I will proceed with my work. I have 0 books in stock and there are 3 people who have asked for the book. What do? Technically, this demand should go unsatisfied, because the books that you are going to receive, that you placed an order 3 days ago, are going to come to you at the end of the day. If they are going to come to you at the end of the day, I can't use them today. They've not come yet. But your institute material says that from the 5 plus 0, which is 5 books, give them 3 books. So you are left with 2 books. Now usually what we used to do is 3 books left, 6, order received, 9 books. You can't do that here, because you are assuming that you've used out of these 5 books. So there is a closing stock of 2 books. The closing for tomorrow becomes the opening for today. I open with 2 books. Question number 1. Opening stock, 2 books. Question number 2. Is there an order outstanding? Yes. There is an outstanding order of 5 books which is going to be received tomorrow. 5 plus 2 is 7. Is it less than 8? Yes. And if it is less than 8, then I place an order of 5 books which will come to me at the end of the 3rd day. From the 2 books in stock, I sell both. 0 left. Is there any order that I am expecting today? No. Then my closing is going to be 0. I open with 0, and again the same problem. I am going to receive 5 books, but in the evening. So if 2 customers come to me, they will have to go back unsatisfied. But what your material does is, your material says 0 plus 5 is 5 books. From that, give them 2. So you are left with, let's do the ordering bit. You open the store with 0 books. 0, is there an order outstanding? Yes. There are 2 orders outstanding. Order number 1 that is going to come today, and order number 2 which is going to come tomorrow. So 5 plus 5, an order of 10 books is pending. If the order is 10, then I won't order because it needs to be less than 8. Then only I order. So no order placed. From the 5 books, I sell 2, 3 remaining. Don't do 3 plus 5, 8. We are assuming that from the 5 we've sold 2. So 3 remaining. So closing stock is 3. You open with 3 books tomorrow. You open the store, 3 books in stock. There is an order of 5 still pending. 3 plus 5 is 8. Will I order? No. If it was less than 8, I would order. No order place. From the 3 opening stock, you sell 1 book. You are left with 2 books at the end of the day. And you are going to receive 5 more. 2 plus 5 is 7. You open with 7 books the next day. Is there an order outstanding? No. All orders are already received. 7 plus 0 is 7. Is it less than 8? Yes. Then I place an order of 5 books, which will come at the end of the 3rd day. But that's not a part of my problem right now. I'm only doing this for 10 days. From the 7, you sell 3 books. You are left with 4. I'm not expecting to receive an order today. The closing stock is of 4 books. And this is it. Apart from these 2 problems, there is nothing wrong with the question. That is my only problem, these 2 parts. They are asking you to find 2 things. Number 1, inventory cost, and number 2, ordering cost. How many times have you placed an order? Order placed. 1, 2, 3, 4. 4 orders placed. What is your total inventory that you've carried? Well, let me do my total inventory. My total inventory is going to be 5 plus 9 plus 6 plus 3 plus 0 plus 2 plus 0 plus 3 plus 7 plus 4 is a total of 39 books carried in inventory. So, ordering cost 4 into, they are charging you 10 rupees for the order. Yes? No, 1 minute. Yes, 10 rupees per order and 50 paise per book per day. Okay. So it is going to be 10 rupees is the ordering cost, which is 40, and inventory is going to be 39 units carried at the cost of 50 paise is 19.5 rupees. So the total cost of this way of ordering is 40 plus 19.5 is 59.5 rupees. Let's check their solution. Here, opening stock, then they've written order received first and order placed later. I prefer a twist. I prefer how you are going through the day. Anyway, how many orders have you placed? 1, 2, 3, 4 orders. Perfect. And 39 units carried in stock. So it is 40 rupees for the ordering and 19.5 for the inventory is a total of 59.5. That's it. Perfect. Let's move on to the second strategy. Let's go to strategy B. What is strategy B? Strategy B is same, just if it is less than 8, order 8 books. Everything else remains the same. So, day and demand. What do? I wake up, open the store and check my opening stock. Day 1, I have an opening stock of 8 books and there is a 6 book order that is coming. 8 plus 6 is 11. Sorry, 8 plus 6 is 14, which is greater than 8. I do not need to place an order. Out of the 8 books, I will sell 3. So, stock at day end will be 5 books. Now what I will check? I will check if I am going to receive any order today. Well, not today. You are going to receive an order of 6 books tomorrow. And now, I hope you understand this. Since I have not placed an order today, there is nothing coming in the next 3 days. This is coming tomorrow because they said so. So, my closing stock is 5 books. What is yesterday's closing is today's opening. I open with 5 books. 5 books in stock. 6 are coming. 5 plus 6 is 11. Is it less than 8? No. Then I don't place an order. So at the end of 3 days, I have no order to receive. From the 5 I sell 2, I am left with 3 books at the end of the day. But I will receive the 6 books that are coming. 3 plus 6 is 9 books. Today's closing is tomorrow's opening. I open with 9 books. Is there an order outstanding? No. There is nothing coming in the near future. Then 9 plus 0 is 9. Is it less than 8? No, it's greater than 8. 9 is greater than 8. Then I don't need to place an order. If I am not placing an order, I am not going to receive anything at the end of 3 days. 9 books in stock. I sell 3 through the day. I am left with 6 books at the end of the day. Nothing to receive. So my closing is 6 books. Yesterday's closing is today's opening. I open the store. What is the stock with me? 6 books. Is there anything coming in the near future? No. No order outstanding. So order outstanding is 0 in other words. 6 plus 0 is 6, which is less than 8, and because it is less than 8, I will place an order of 5 books which will come at the end of 3 days. Sorry, I have to order 8 books here, extremely sorry. 8 books which will come at the end of 3 days. I have 6 books with me, out of which I sell 3. I am left with 3. No order being received. 3 plus 0 is 3. I open with 3 books the next day. Is there an order pending? Yes, there is an 8 book order that is coming. Well, if there is an 8 book order that is coming, then 3 plus 8 is 11. 11 is greater than 8. I don't need to place an order, which means at the end of 3 days, I am not going to receive anything. Out of the 3, all 3 are sold. I am left with 0 books, nothing to receive, so 0 books. Yesterday's closing becomes today's opening. And here again the same problem. I wake up, how many books in stock? 0. Is there an order outstanding? Yes, there is an order that I placed 2 days ago, which is going to come tonight. So that order of 8 plus the 0 is 8. Is it less than 8? No. If not, then I will continue without placing an order. So I have nothing to receive at the end of 3 days. But again, if my demand is 3 books and I have nothing in stock, where do I give anybody anything from? What they are saying is, give them from the 8 books, which I think is wrong, because these books are going to come at the end of the day. 8 minus 3 is 5. Now don't say 5 plus 8 is 13. This 5 is out of this 8 only. So closing stock is 5 books. Today's closing is tomorrow's opening. I open with 5 books. Is there an order coming in the near future? No. 5 plus 0 is 5, which is less than 8. Then order 8 books today, which will come at the end of 3 days. From the 5 books you sell 2, so you are left with 3 books. Nothing coming today, so 3 books left. Yesterday's closing becomes today's opening. You open with 3 books. Is there any order outstanding? Yes. There is an 8 book order outstanding. 8 plus this opening 3 is 11. Is it greater than 8? Yes. If it is greater than 8, do not order. You will not receive anything at the end of 3 days. Out of the 3, I sell 2. I am left with 1 book. Nothing received today, so 1. Yesterday's closing becomes today's opening. I open the store. I have 1 book in stock. Is there any order that is coming? Yes, there is an 8 book order coming. 8 plus 1 is 8, 8 plus 1 is 9, which is greater than 8. Then I don't place an order. And out of the 1, I sell the 1 book. No book left. 0 books left with me. 8 I am going to receive at the end of the day. Total is 8. I open with 8 books. Is there any order outstanding? No. So 0 order outstanding plus 8 books in stock is 8. Is it less than 8? No, it is 8 exact. Then no need to order. From the 8 you sell 3. You are left with 5 and the closing is 5. This is it. How many times have you placed an order? Twice. Let's check what the inventory in this case is. Yes. 5 plus 9 plus 6 plus 3 plus 0 plus 5 plus 3 plus 1 plus 8 plus 5 is a total of 45 in this case. Cost is going to be ordering. 2 orders at 10 rupees is 20 and inventory. 45 books at the rate of 50 paise is 22.5. Total is 42.5. The previous strategy gave me a total of 59.5. This one gives me a total of 42.5. It's expensive to carry the inventory, but it's cheaper to order. This was expensive to order and cheaper to carry inventory. So can I say this option B is a better option? They don't ask these kind of questions. I don't know why they put them in the sheet then if they don't want to ask. But then because it is there in your material, I have to teach. This is the last question in simulation. Let's just check if their answer is the same. 20, 22.5, 42.5. Yes, 20, 22.5, 42.5. So option B is better because it has low inventory cost, or the total cost is low. That is how I would put it. Again, my problem is here. When you have nothing in stock but you have a demand of 3, you are picking up from something that is yet to come in the evening. But then that is how they have done the question. So we also have to do it in that way. And this is it. This is going to be the final answer. With this, the chapter simulation comes to an end. Thank you very much.